differentiating both sides with respect to x, that means differentiating it, matlab differentiation of with respect to x, d by dx. It's just we are putting d by dx on both sides. So like left hand side we have cos sine square x plus cos square y. So different d by dx of this is equal to d by dx of here. If in the first left hand side you can see here we have to use the derivation, like if you remember u plus v dash is equal to u dash plus v dash. That means it means that differentiating sine square x plus differentiation of cos. It's just d by dx will be attaching with the both. D by dx of 1 is constant. Since the differentiation of constant is 0, so the answer is 0, right hand side. Here we know that whenever we have some power thing, like d by dx of x square is dx 2x. But suppose I have d by dx of y square. So you will first of all you have to use the algebraic expression, matlab it will become 2y. But since you are differentiating with respect to x, you have to put dy by dx. So that will be the answer. Right? Here also similar manner. First of all, you have sine square x, matlab power to be solved. It will be 2 sine x. It's like x square ka 2x. So sine square x ka 2 sine x. But since we are using the chain rule, we have to use again the same. You should not forget this sine x. We did not differentiate of sine x. Sine x is not differentiate yet. We just solved the power of sine x. So here the right part also, the next term also, we are going to do the similar method. So in this place, cos square y, we have 2 cos y. Whatever the angle is, angle was y, and here also we have taken same angle. But since we have to use the chain method, we did not differentiate this term. That is how we have to do. If you get confused, we can have another funda also. Suppose you have to differentiate to understand this properly. You need to you are going to do this. Okay, suppose you need to do this d by dx of sine square x. Okay? D by dx of sine square x. So suppose you are putting sine x as a t. That means what will be your dt by dx? Matlab you are differentiating with respect to x on both sides. So d by dx of sine x, it's just you are doing differentiation on both sides, okay? Because you are going to assume this. So it's like d by dx of sine x is cos x, and which is equal to dt by dx. So that means if you substitute this over here, you are going to do d by dx of sine square x, which is nothing but t square. Because you assumed sine x as a t, it is t square. So t square ka like a differentiation is 2t. But since the differentiation with respect to x, you have to differentiate this dt by dx. Dt by dx is also coming with dt by dx. But 2t, what is your t? It is sine x. And dt by dx, what is dt by dx? So we have found that it is cos x. That is how we get the answer. Okay, what is d by dx of sine square x? So that is the other method, t method bola tha humne. Okay. Here we are going to use direct method, ye expert method hai. T method is basic method. So sine x ka cos x. And still we have to do dx by dx. Suppose the angle is x square, we had to do x square. But here by dx by dx, which is 1, no need to do further. Here 2 cos y. D by dx of cos y. Cos ka minus sign. But still the angle is y, not x. Dy by dx. Since we have to find out the dy by dx only, we have to make dy by dx as a subject. So let me take it that side. So it's like 2 minus 2. Here I am keeping cos y, sin y, left hand side. dy by dx. And that side I'm taking this minus 2. It become minus because I'm taking that side. So it's like minus minus got cancelled. And this is 2 cos y sin y. It is like we have learned that it is nothing but sin 2y dy by dx. And there it is sin 2x. Whatever is your angle, you should check your angles. Your angles in terms of x. So funda says, matlab the identity says, if you remember your identities, sin 2 theta is equal to 2 sin theta cos theta. We can use that easily. So that is why your dy by dx is equal to sin 2x upon cos 2y. Sorry, sin 2y. So that way only we are going to do. Just you have to remember the funda, how to differentiate, what are the rules and identities and trigonometry. Trigonometry things. Otherwise, it will be very difficult. Next, 9th one. From this onwards, all the fundas, most of in all these identities, I'll tell you what to be remembered. याद कर लेते हैं. Last year's identities. Let us remember some identities. Will be very useful. You can write in a margin. You are going to use this. Sin 2 theta in terms of tan theta. It was 2 tan theta upon 1 plus tan square theta. This write down in the margin. Will be helpful to you. Cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Once you will have this in front of you, no, it will be easy to solve 9th onwards, because you will only tell me, okay, now this one will assume and all. That way you can say tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta upon 1 minus 3 tan square. I think it's now enough. If it is required, this 4 will be useful. And cos 2 theta, tan 2 theta, and cos tan theta. Okay. So now you can see that. Again, one more thing should be revised. Okay, by sine inverse of sine theta is theta, if you remember. And sine of sine inverse theta, that is also theta. So if we would get somewhat like this, will be very easy to differentiate even. Sine inverse of sine theta. Okay, this is to be remembered. So now you will see. What should I assume as x? So my question will become so easy. So you just check the first formula which we did, sine inverse of, then check sine 2 theta. Because here you have sine inverse. That means I want to make this bracket in terms of sine 2 theta or somewhat like that. So sine will go and only 2 theta, only the angle will be your answer. Y is equal to that angle. Okay. So that way we will differentiate after that. And it is very easy. Our goal is to find out the dy by dx. Okay. Since you are going to like assume in terms of theta and all, but ultimately our goal is to find out this only. So here, what do I do? Here let karne ki zarurat nahi, y already is given. So, but we are going to put, not let, but we are going to put x as a tan theta. Now your picture is very clear now. That means if you just check sine inverse of 2x, x matlab tan theta, and 1 plus x square, it's like tan square theta. We have used already in this, all these things. So sine inverse 2 tan theta upon 1 plus tan square theta. That is the reason we have set it. I know that it is sine 2 theta. And sine inverse of sine 2 theta. I know that sine goes. Actually, we should not say cancelled out, but just to like switch to that easy part. And you can take 2 theta is the answer. So 2 theta, let us put value of theta. What is the value of theta? On top only we should write what is the value of theta. So your theta is nothing but theta is equal to tan square x, tan inverse x. Okay, x is equal to tan theta. Theta is equal to tan inverse of x. Simple. So 2 theta, theta is your tan inverse x. And now if you check your inverse trigonometric differentiation formulas, then we'll be getting easily this one. So we have derived also. So differentiating both sides with respect to x. That means dy by dx. And here it is 2 goes actually outside, but let us do this from the initial part. Later on we'll jump the steps. The first ninth one will do each and everything. So 2 is constant. Since 2 is constant, it goes outside. So it comes like this, dy dx of tan inverse x. Tan inverse x, our differentiation is 1 by 1 plus x square. So 2 into 1 by 1 plus x. X square. What should be this x? Whatever is your angle. Your angle square. So dy by dx is equal to 2 by 1 plus x square. Start the next one and start thinking that what should you assume so that your funda you'll be getting in easy way. Three x. And also I showed you what it should be because it is tan inverse. Since it is tan inverse, my bracket I want to turn into 10. So 3x x cube. The funda, what we are going to put. So here you are going to put x as 10. So your theta is tan inverse x. We'll write out this theta also so that later on you are going to substitute. Obviously, the theta was not given. We have assumed it to make this question simpler. So we have to convert it also in terms of x before we start doing differentiation. That is why we are finding theta also. So my y turns it be 3 tan theta minus 10 cube theta upon 1 minus 3 tan squared. Know the formula? It is tan inverse of 10 3 theta. So y is equal to 3 theta. Y is equal to 3. What is the theta? Tan inverse x. That means differentiating both sides with respect to x. dy by dx is equal to dy dx of 3 tan inverse x. 3 goes outside. The differentiation, because since 3 is constant, it always goes outside. So dy by dx is equal to 3 into 1 by 1 plus x square. Dy by dx is equal to 3 by. So you can see both are similar questions. Even the next also, if you see, you will easily understand. Easy. 11th you see, y is equal to cos inverse 1 minus x square 1 plus x square. Put x is equal to, most of the questions are going to have tan theta only. Theta is equal to tan inverse x. That means your y cos inverse 1 minus tan square theta 1 plus tan square theta. Y is equal to cos inverse of cos theta. Y is equal to, since we had cos inverse, we tried to convert that bracket 1 minus x square upon 1 plus x square in terms of cos 2 outside, cos inverse, inside should be cos. Then only the 2 theta would be answered. And y is equal to 2 tan inverse. Differentiating both sides with respect to x. Dy by dx is equal to d by dx of 2 tan inverse x. dy by dx is equal to d by dx of tan inverse x. dy by dx is equal to 2 into 1 by 1 plus x. So dy dx is 2 upon 1. So you see similarity. All are almost similar. If you try to do the next one, you feel that it is also similar question. If something here or there, next question, little funda is there, just need to apply in one trick need to be done in 12th question. That we are able to see. Put x is equal to. Now you know that if I want sine 2 theta inside, I should have 2x upon 1 plus x square. But here I have 1 minus x square upon 1 plus x square. ये तो कहीं अपना cos 2 theta है. So anyway, we are going to use that only. But cos 2 theta, we know how to convert. Because my cos pi by 2 minus theta, conversion, sine theta. And sine pi by 2 minus theta. Whatever I write at side is right at side, otherwise you can write on top. Division will be easy. So x is equal to tan theta only, you please. And theta needed to be again substitute. So theta is equal to tan inverse. Your y is equal to sine inverse 1 minus tan square theta and 1 plus tan square theta. That means it is so cos 2 theta but should have sine inverse and sine only, then only 2 theta would be our answer. So let me use some trick of that thing only. We are going to do sine of pi by 2 minus 2 theta. Because cos theta is sine pi by 2 minus theta. Minus theta. If theta is the angle of cos, then you would do pi by 2 minus theta. If 2 theta is the angle, then you will do pi by 2 minus. So that has to be seen properly. Y is equal to pi by 2 minus 2 theta. Because sine inverse and sine will be removed. And you will be having pi by 2 minus 2 theta. Let us substitute theta. Pi by 2 minus 2 theta is tan inverse x. Now we can again write differentiating. So dy by dx is equal to d by dx of pi by 2 minus tan inverse x. d by dx of pi by 2 minus, I'm taking 2 outside since it is constant, tan inverse x inside. So you see, it's d by dx of pi by 2 is constant. The differentiation of constant is 0 minus 2 differentiation of tan inverse x. Now you already remembered at least one differentiation, tan inverse x. So this minus 2 on 1 plus. So if little bit of change is there, we'll do accordingly. Should be done so that we would get again in the form of sine inverse and sine, cos inverse of cos, tan inverse of tan. We know how to. Small trick was used. Similar manner you can see over here, 2x upon 1 plus x square. It's like if you assume x is equal to tan theta, you will get sine 2 theta. Obviously, you can see, yeah, we are going to use that method. So try to do it. X is equal to tan theta. Your theta is equal to tan inverse x. Just try to do it. I'm giving you 1 minute. 1 minute. Just like second last one. Here also we have to put. In this case, you have to think little bit and use because you know what? Here it is 2x. If you take tan theta, no, there is nothing with under root of 1 minus x, 1 minus tan square theta. Because 1 minus tan square theta, so we don't have any formula on this. So which formula do you have? Even 1 minus cot square theta also, you don't have any formula of this, which will be useful. So we have 1 minus cos square theta or 1 minus sine square theta. So if we could make this like this, so it will be cos under root of cos square theta, which will turn to cos theta. So that under root part can be converted into cos theta if you choose x as a sine theta. If you take x as a sine theta, 1 minus sine square theta is equal to cos square theta. And 2x, x matlab you have already sine theta over multiplied. 2 sine theta into cos theta, sine 2 theta. So that formula will be used if you remember sine 2 theta is equal to 2 sine theta into cos theta. We used it today also. So that manner only we will use. Put x is equal to sine theta. Simply you can take sine theta. So theta is equal to sine inverse x. So wisely, you should use all this, not tan theta all the time, since we don't have any formula here would work. So it's 2 sine theta. Let's show the steps. At least teacher that, yes teacher, I know how to solve it. So y is equal to sine inverse 2 sine theta into cos theta, because 1 minus sine square theta is cos square theta, under root of that is cos theta. As it is the other part, and you can see that 2 sine theta into cos theta is sine 2 theta. Sine inverse of sine came together. That's our adjustment, and we got 2 theta is the answer. And since I know what is theta, it is sine inverse x. Theta is sine inverse x in this case. Every time we used to take tan theta, but this time we use some different. According to the question, we have to think little bit. So differentiating both the side with respect to x. We get 2 is constant. You can go outside to do d by dx of sine inverse x. What is the differentiation of sine inverse x? Is into differentiation of sine inverse x is under root of 1 by under root of 1 minus x. dy by dx is equal to 2 upon the root of 1 minus. So according to our requirement, we have to do the arrangement. Even the next, maybe you have to think a little bit and we'll do. So let's do it. Sec inverse, that means inside part I have to convert it into sec. Sec matlab 1 by cos. If I get denominator as cos of something, I'll get sec inverse of sec something. So let me put this x in terms of something like that. So see that here I am putting x is equal to cos theta. Okay. That is cos inverse x. Why so? With practice, you will get. Have to do the extra questions also accordingly. With the practice, you will understand. By looking at the question only, you will find out later on. Here we can use this identity. For this, you have to have trigonometry practice. Because 2 cos square theta minus 1, all these things, everyone does not remember all this identities. So it is 2 cos square theta minus 1 is cos. 1 by cos. 1 by cos is sec. Whatever the angle is 2 theta, so sec is also having sec inverse of sec. That means theta is answer. Theta is differentiating sides with respect to theta. Dy by dx is equal to this outside. Constant does not differentiate. It's constant, not vary. I can take notes. It's minus 1 under root of 1 minus dy by dx minus 2 under root of 1 minus